First lab for Intro to Mechatronic Systems 2, you're going to develop a decimal to binary converter for bits, but now you're going to apply the descending and power method. As a challenge, if you finish that one, I want to see if you guys can build a binary to hexa and a binary to octal converter. You're going to upload a zip file with your VI solutions. If your solution has more than one VI, include everything inside of just one zip file. And you're going to name that zip file the following way: first and last name underscore lab1.zip. So you have an example here, Dina Riva lab1.zip, so don't forget the underscores. This will allow me to correct the labs. It will make my life easier to correct the labs. You have one full day to develop your solution, so Saturday, April 11th at 10 a.m. And no need, do your best to give your solution, even if it's wrong. Don't worry, you just do something, upload, you get full credit, and then I'll post the solutions. So avoid copying or getting source code from someone else. Try to do your best to learn. And I'm going to just give a quick review about the descending powers and subtraction method. So you learned two. Wednesday you developed the division with remainder. Now we're going to do the power and subtraction. So pretty much what you need to do is you need to evaluate, well, first of all, you are just doing for 4 bits. So we're just worried about from 1 to 8. Then you're going to evaluate the number and you're going to compare with the decimal weights. And if that comparison is greater or equal than the number, then you're going to subtract and propagate that result. If not, you just propagate to the next spot the number 8. I'm going to give you some help here so you don't wonder too much about what can you use. There are different solutions for this. One of them is if you go to the comparison module and if you use this select over here. So let's pick it up, comparison, select. And now if you're wondering like how is this module working, on the top corner over here you have a question mark. You're going to press that question mark. It's going to open this context help. Now if I press the module that I want to get help, this is telling you how the module works. So notice that it has 3 inputs and 1 output, and the selection, which is the middle one, is a boolean. So if it's a true or false. If it's true, the value t, whatever you put here, is going to pass to the output. If it's 0, if it's false, then whatever you have here is going to pass on the outside. So how do you test this if you want to test before you start developing or including this in your solution? Let's right click and create a constant on the top. Let's put the number 5. And let's do the same thing on the bottom one. And let's create another constant. And I'm going to put the number 2. And on the middle one over here, this one, I'm going to right click and create a control. When I create the control, notice that on your front panel it added a button. So I'm going there, pick up this button, put it here in the middle so I can see what's going on. Alright, go back to my block diagram, and then on my output I'm going to right click and I'm going to create an indicator so I can see, and I'm going to name it result, so I can see the result. Alright, I'm going to select it on my front panel, put it here, and I want to run these a little bit more often than just one time. So notice if I press this white arrow, it only runs the program once. So I'm going to do a right click and put all this code inside of a while loop, and I'm going to create a control, another button so I can exit my loop and terminate the program. Alright, perfect. Let's run the program. Now I have the program running. Look how cool it is now. If this is 1, number 5 will pass. If this is 0, number 2 will pass. So number 2 is passing because I have a 0. If I have a 1, number 5 passes. And this is how you make your selection. So if you go back to your descending power and subtraction method, you're probably going to use that module to decide if you're going to pass the result of the subtraction, in this case, for example, 72, or if this doesn't hold true, you're just going to pass the 200. So what other modules are going to be beneficial? So you have the select, and another one that is going to help you. If you right click and you go to comparison, you're going to also need this greater or equal. This is going to be the one that you're going to do the comparisons with your decimal weights. So let's put that one there, and you do exactly the same thing. If you don't know how it works, pull your question mark, press the module, and it tells you how it works. It's going to compare these two inputs, and if x is greater than y, it's going to give you a true, otherwise it's going to give you a false. So you test it exactly the same way. You can create an indicator. We can do an indicator for now, so it's going to be a 0 or 1. So in this case, it's putting an LED. And the two inputs, let's create a constant. Create the constant on one input. I'm going to put the value 4. And let's make it a little bit more dynamic, just for testing. And I'm going to create a control so I can change that output instead of having just a constant. All right, I'm going to run the program. And now notice that 4 is greater or equal than my number y, which is 0. So I'm going up. 4 is still greater than 1, still greater than 2, still greater than 3, still greater or equal than 4. But if I go 5, now you can see that it gives you 0. So this is going to be also an important module that you can use during this part of your algorithm. And that's pretty much it for now. So I'm not going to reveal more than this. Hopefully this gives you like some guidance so you can develop your algorithm, and you're going to focus only on 4 bits. So I want just the code for a 4-bit descending power and subtraction method.